Hi, this is Sanghavi, Assistant Professor, Department of Pharmaceutical Chemistry. I welcome you all to the MOOC series, a nice initiative taken by LJ Institute of Pharmacy. Today, we are going to talk about the stereochemistry of steroids. Last time we have discussed about the nomenclature aspect of steroids. Now, today we'll see how stereochemistry plays very important role in the steroids. Let's see. As far as stereochemistry part is concerned, we always say it plays very important role as far as biological activity is concerned. And when we talk about the stereochemistry, three important aspects we must have to discuss. Number one, optical isomerism. Number two, geometrical isomerism. And number three, conformational isomerism. Fine. Now, let me say in case of steroids, optical isomerism. When we talk about optical isomerism, 3 to 4 points comes into the picture. Number one, how many chiral centers are there in structure? Based on all those chiral centers, number of stereoisomers are produced. And we all know very well, each and individual stereoisomer plays very important role in elicitation of biological activity. Fine. Next is, we have to talk about the configuration. In case of steroids, RS configuration is always there, but as far as basic moiety is concerned, we always have to talk about alpha and beta configuration. Fine. Next is a very important aspect when I talk about the configuration. If any chiral center is present in the side chain of the molecule, not in the basic steroidal nucleus, but in the side chain, then definitely we have to talk about the RNS configuration. Now, let's see in case of basic steroidal moiety, the first aspect, that is how many chiral centers are there in the structure. Now, you can see when steroidal moiety is there, basic steroidal moiety, two ring system, when they fuse together, the fused carbon are always considered as a chiral center, because these fused carbons are attached with 3 different carbon and 1 hydrogen. Rest of all the carbons are having CH2 group. It means what? That carbon is attached with 2 same substituents, that is hydrogen. We all know very well. Fine. Now, when we talk about basic steroidal nucleus, we say 5 chiral centers are there, that is 5, 8, 9, 10, 13 and 14. Basic nucleus. I am talking about right now not individual steroid but basic nucleus. So number of stereoisomers we all know very well. The formula is 2 raised to n, where n is number of chiral center. So 2 raised to 6, of course 64 optically active forms are possible. Now suppose if any fused atom is involved with another carbon, double bond formation, then what will happen? That carbon is now no more chiral. You can see the third structure, that is a particular steroid where there is a double bond between position number 4 and 5th. So now 5th carbon is not said to be a chiral because it is having double bond with the carbon number 4. Generally, we always say that dark bond is there, substituent, or if it is a hydrogen, that is above the plane, so that is having beta configuration. If I talk about the dash bond, that is a backside of plane, of course we say dotted bond, that is alpha configuration. Fine. When I talk about the aliphatic side chain at carbon number 17, majority of cases it is assumed to be the beta configuration. Here I have mentioned this side chain in the steroidal nucleus. You can see the bond is dark bond and dark bond solid bond. It means what? That is a beta configuration. Fine. Another aspect of the isomerism, stereoisomerism, is geometrical isomerism. As Geometrical isomerism is possible in three different cases. Number one, when double bonds are involved. Number two, cyclic aliphatic structures are there. Definitely it is involved. And number three, very important part is fused bicyclic ring system or polycyclic ring system. We always say cis and trans isomerism is possible. Fine. Even if they are not substituted, but still we have to say it is a trans or cis. Here you can say in the first structure, we say fused ring between A and B. Both the bond are solid bond. It means both the substituents are having beta configuration. Beta means what? They are on a same side of plane. Of course, we have to say it is a cis isomer. Similarly, cis trans is also possible in case of B and C ring system. In case of C and D ring system. So whenever there is a fusion, we always say cis trans isomerism comes into the picture. Now, steroids may have either cis or trans isomerism, undoubtedly. But as we all know very well, trans is more stable as compared to cis. So majority of steroids involved trans configuration. But in case of the special molecules, that is cardiac glycosides, where we will usually find the cis configuration instead of trans configuration. Fine. Next is last not but least aspect, that is conformational isomerism. We always say it is hydrocarbon nucleus, cyclic aliphatic structure, because double bonds are not there. So of course, when we talk about A, B and C ring system, it is a purely cyclohexane moiety. And when I say cyclohexane moiety, four conformations comes into the picture: chair, boat, twist boat and half chair conformation. Already we have studied in semester 4, that is a conformational isomerism in cyclohexane. That chair conformation is most stable conformation as compared to boat, twist boat and the least stable conformation, that is a half chair conformation. Now in case of steroids ABC, the cyclohexane moiety is always having chair conformation, but last ring system, that is a fused moiety, cyclopentane moiety, here we have to say it is a half chair conformation. Fine. We all know very well chair conformation is the most stable because what you can say, due to less angle strain, or what you can say, the strain exists in the conformer is less, and we always have to say chair conformation is more stable conformation. Here one more presentation part, that I have mentioned the two structures in both the format. In case of first above structure AB trans steroid, another structure ABC steroids, on right hand side I have mentioned that both the structures in a conformational form, so that you can clearly distinguish how it is to be drawn in the paper. But as far as conformational isomerism is concerned, it is difficult to draw on the paper because there are three cyclohexane ring system fused along with one, that is cyclopentane. Chair and the half chair conformation makes the structure more complex. But when we talk about the simple structure without conformation, it is really very easy to draw. You can say when I talk about geometrical isomerism, always cis trans comes into the picture undoubtedly, but we not always say that fusion between A and B is trans, B and C is trans, C and D is trans. No, it may be trans trans trans, it may be cis trans trans, or it may be cis trans and cis. It is always possible, I say. Fine. So it's not always we say that all the ring system must be trans. It's not like that, because the structure is a little complex. Fine. So we always have to talk about the stability as well. No doubt trans isomer is more stable, but when there is a complexity of the structure, it may be possible that some of the ring system, fused ring system, more specifically it is the cis configuration, it is again the stable one. Fine. Frequently asked question, if I talk about, that is discuss in detail about stereochemistry of steroids, the whole aspect, the three aspect you have to discuss in the paper. Another one is either they ask only conformational isomerism or they ask only the configurational isomers. So make sure when we talk about stereochemistry aspect, it is not a part of nomenclature, but many of time in exam they ask a combined question, discuss nomenclature and stereochemistry of steroids. You all have to mention the basic points of nomenclature as well as all the three aspects of the stereoisomerism. But suppose if they ask only the conformational or configurational or rather only stereochemistry part, you must have to mention all those points which I have mentioned in the presentation, as well as you have to mention the structures, because when they ask in 5 marks stereochemistry, you always have to mention the structures. Fine. As far as the reference are concerned, I can surely say Wilson is one of the best book to refer steroids, because they have given stereochemistry of steroids in a very nice way. Foy is always the best. Thomas is again a very good book. So when I talk about the question aspect, that is the stereochemistry of steroids, you have to remember all those 3 different types of the aspect: optical isomerism, geometrical isomerism, and of course I can say that is a conformational isomerism. Fine. Thank you for watching the presentation. Please like, subscribe our YouTube channel, that is Pharma Ignite. Thank you all.